Let's begin. Today is our second lecture. I want to pick up where we left off last time, and we'll dig based on some feedback from all of you. We'll dig in a little bit into Python to help ease the anxiety and the pressure, and show you that if I can do it, you can do it, and you're going to come out of this class knowing more than you know now about Python and programming. Okay. So last time when we left off, I tried to stress the concept that programming is not a language. There's something called programming language, right? Which is Python. Python is a programming language. MATLAB is a programming language. C, C++, Java, all of those are programming languages. But that makes that different from the programming itself. What matters to me and what matters to you in this class and in your career in general is understanding the concept of what you need to program before you pick the language that you program it in. So the analogy I give is, think of language and ideas. An idea in your mind can be expressed in different languages. That's how you communicate with different people with different languages, right? It's the same idea, but you communicate it with different languages. What matters is the idea itself, and how you expressing it is just an option that you have. With programming, you can choose Python, MATLAB, Java, whatever, but what's important is the programming idea itself. What that means for us is when you have a problem, you need to plan what you need to program first. Say you, as we're going to do next week, maybe if we have time today, you're computing errors and comparing errors between two different methods. What you need to think about is say, okay, I have a list of points I need to compute the error at. How am I going to program this? I can make an array. An array is a concept that is not associated with a language. It's a programming concept. I make an array, I put the values in the array, and then take the difference between those two arrays and divide them by another array. That will give me the error. Okay, that's great. That's the idea that you need to look for. Now, the language comes in how to express the idea to write it and get a result. That's where you choose Python, MATLAB, etc. Here we're doing Python. As long as you know what you need to do, my claim is that it's easy to do it because you have resources from Google to GPT to me to the TAs. You come to us like, how can I take the difference between two arrays? Oh, just put array A minus array B, and you get a difference, right? So that's it. That becomes, if you know what you need to do, then programming it is the easier step. But you need to know what you need to do first. In some cases, it gets harder. You need to say, I need to sort an array, for example, and then transpose it. Those are words that are rooted in math and in programming, but not in the language itself. Then you go and ask, how do I transpose an array or a matrix in Python or in MATLAB or in C++, right? And you get a different answer for each because those are different languages. So if you think of it this way, that allows you to hopefully ease your anxiety about this, to separate it into two categories. Category one, what do I need to do? And frankly, you don't even need to be a programmer to know what you need to do. So like if I have a list here, the word list has nothing to do with programming, right? You have a list of groceries, right? You take two different lists, you can compare them to each other, right? That's not a programming concept. But if you know what you want to do, then you can look up how you do it in a certain language, okay? Now, why did I choose Python for this course? Why is our department pushing for Python? To tell the truth, well, we're always trying the truth, but to be historically accurate, in 2017, we started this revolution in our university. We were the first department to tell everyone, guys, we need to move on Python. Python was this little kind of programming language that was kind of in the back alley. Nobody was talking about it, but it was kind of gaining some passion and a good following. It was free. It was so easy to program. You can just open up a Python code and write something, and we'll give you an answer. Go try C++. You have to write the code. If you miss a a brace in it. It's not, you need to compile it then, and then you need to run the executable. It's a nightmare. Even compared to MATLAB, Python is incredibly easier because in many cases it actually allows you to add apples and oranges, which would be wrong, but it at least gets you somewhere, okay? It at least gets you somewhere. And, you know, we saw this early on. It was Professor Butterfield and I. We were in San Francisco at the AICHE conference. We're sitting at dinner, and we were just having a good time. And we're like, you know what? Let's move everything to Python. And within a semester, we moved everyone to Python. Now, other departments are starting to catch up. And soon enough, I tell you, in a few years, we're going to move away from Python and pick up the next best language, Julia maybe. And, you know, everybody will still be doing Python. We will be on the next kind of hot thing. So now, why Python? I have a list of things. First of them is that it's free forever. You have to pay for a license, and I know how much you love to pay for licenses. So for Python, unfortunately, you don't have to pay for a license. You'll get it all free, okay? It's very easy to get started programming with Python because it allows you to get answers. Like I said, sometimes allows you to add allows you to try to add apples and oranges. It's like this, you know, if you're using a PC, or even Mac now, you try to install something in the operating system. I cannot install this because it's incompatible with this operating system. Would you at least try? Like just, you know, dump the files, put them in the folder, and try it. So Python will try it for you. If it doesn't work, gives you an error, and then you will learn something from that error. Okay, so at least it will try it for you. Python is in very high demand. It consistently ranks between number 3 and 5 in terms of top programming languages. So it's going to give you an edge. If someone reads on your resume, oh, you know, Visual Basic versus Python. Oh, they know Python. You know, that's better off. Okay, so you have a little bit of an advantage over others. It's very forgiving. Like I said, adds apples and oranges. Allows you to make mistakes, which could be argued that that's a bad idea. But in my opinion, it actually allows you to learn a lot because it tries to do something for you. There's a significant community support around it. It's all free. You know, Stack Overflow and like Google, just anywhere you go, there's some Python example doing something. I guarantee you go Google anything now and say, I want to do this in Python. I want to create, you know, the shape of something in Python. You'll find a code example for that, okay? You can use Python in a web browser. Historically, that was my primary motivation. When I first taught numerical methods in 2017, we were doing MATLAB. And man, the transaction cost to get to MATLAB was so annoying. You have to download the software, connect it to the license. If there were not enough licenses, it will kick you out. And you have to open up this environment, write the code in one file, dump the plot in another file, and then collect them together, put them in Microsoft Word. It's very annoying. Python, with Jupyter Notebooks, you do everything in one file, in one document. That's incredible. Now it's like, oh yeah, we know Jupyter Notebooks. At the time, this was like, you know, revolutionary, okay, the idea of what we're doing with Python. And you can use Google that's my favorite way to learn Python. Believe it or not, I still Google things because I'm not gonna memorize how to make an animation of particles in a flow. It's like 200 lines of code. I'm not gonna remember that. I always Google it. Every time I find a different answer, but I can interpret the code and understand what they're doing and fine tune it to what I want. That's totally okay because we're not producing people who are gonna be learning just the programming for the sake of programming. We want programming for the sake of solving serious problems, okay? All right, so it's okay to Google it. It's okay to, you know, augment yourself with those tools. That's fine. That's all allowed. Okay, now there are 2 ways to access Python. The first one, which is kind of the easy way to get you to do Python, eventually everybody moves to the second approach, but the first one is directly through your web browser and the Center for High Performance Computing. So you don't need to install anything. You don't need to worry about dynamic link libraries in Windows or other nonsense that the operating system is going to spew at you. You just go to a website and run Python in that website. So the description is put on the syllabus on the front page in Canvas. I know many of you already signed up. CHPC is the Center for High Performance Computing at the University of Utah. Is this building just a little bit southwest from this direction. They were also the first in collaboration with us to create what we call this Jupyter Hub. I'll talk more about that in a minute. But to create this central place where our students can go and write Python code. This is great. All you have to do is just have an internet connection. Okay? You go in there, and you can just start programming and coding. You do need to sign up, because we're important. You need to sign up. So the discussion about creating a CHPC account on the slides, on the syllabus, on the front page of Canvas, go ahead and do that. You go and apply as a student for an account, and you put in this information. This token is very important. And you indicate which semester, and this will end shortly, this subscription period. And so by mid-September, everybody should be signed up. So once your account is set up, then you can access Python just by going to this website, ondemand-class.chpc.utah.edu. You go on there, and you see a bunch of apps. We're all familiar with apps. There's one called CHEN Jupyter. You just click on that, and you're on it. Okay. The second way is to download your own Python distribution. Okay, so this is just installing Python locally. And the most popular way is called the Anaconda distribution. So what do I mean by that? Different companies make different distributions of Python. Python is still the same programming language. They all behave the same. But different companies have decided to, because it's free, they decided to package Python in different environments and distribute it so that you sign up with them and they get more user accounts and whatever. The most popular one is just the Anaconda distribution. I guess they used Anaconda because Python is, the viper or snake and whatever, and the Anaconda is like a bigger snake or something. They're onto something, I'm pretty sure. But, Anaconda distribution, anaconda.com, just go download the thing, install it, and then you have Python locally. You can run it locally. Okay? Either way, I don't care. The advantage of this is that you have it, you don't need an internet connection for this to work. This one, you need an internet connection. This one, you have to install something, but once it's in there, it's good to go. Okay? I cannot provide you IT support. Like if you have a problem with the installation on your laptop, I can try to figure it out. But usually, there's like so much variety in these operating systems, I can't really debug it for you for the installation if you're having problems with the installation. So then you'd opt for this one instead. It just works, and it's very convenient. OK, so it is your responsibility to learn Python. Again, I'm not trying to scare you, but I want you to be anxious enough to put a serious effort, because I cannot learn it for you. I can teach it. I can take down the barriers, but in the end, you have to commit. You have to type in the code for it to stick in your mind. It doesn't help me if I do that. I can do it for you all day long, but that's not helping you, OK? So you need to learn it. Now, I will help you. We will do work in class together, code a lot of coding examples, and your homework assignments are going to be incremental challenges over what we did in class. So pay attention to what we did in class, go back to the lecture, repeat what we did, and usually I'm asking for a little push forward. Okay, like do the same thing we did in class, but do it for 10 more values or 1,000 more values. Okay, so essentially, put it in a for loop as you will learn as we go along. OK. You will pick up tips and techniques in class, and the syllabus is full of resources to learn Python. And one of them, so you're welcome. There's a lot of resources in the syllabus, and I know that can seem daunting. And usually, most students don't go there. Some do, and they learn a lot. If you don't want to go on those resources, you have to at least do this one. It's called EasyPy that I put together a few years ago. And that should be just enough to get you to do all of the things we need to do in this class. Okay? So this will be on your first homework assignment to go through these slides. I'm going to go through some of them together with you now, just to show you what they're about. And so if you click on that link, the PDF slides should be on your Canvas, by the way. So you can follow with me if you want on your own computer. Okay. But I'll move this here. So these slides were actually created with Python, not in Keynote or PowerPoint. They were created as a Jupyter notebook that I converted into slides. So you can imagine you're writing a report in your job later, and your boss tells you, oh, I need slides pronto. OK, you're like, oh, crap. Convert your Jupyter notebook into slides. and then you go present them as slides. Okay? I do that all the time. Okay? And people think I'm always ready, but I'm not. All right, so let's see. So with this, you navigate it with just simply pressing the arrows on your keyboard, left and right or top and bottom, arrows on your keyboard. All right, so this is where I kind of explain my philosophy about programming. Like, as long as you know what you need to program, the next step is ask the question, how can I program it in Python? How can I sort an array in Python? How can I multiply two arrays in Python? How can I create a transpose of a matrix in Python, and so on. So you just Google that or put it in GPT and give you an example. Then you apply it to your own, to what you're trying to do. Okay? And I keep moving forward here, and we came up with this thing. If you love movies, if you've watched Ratatouille, Anyone Can Cook. Probably that's kind of an old movie now. It's like this movie about this rat who has an insane sense of smell, but he loves to cook, and so he starts controlling this mediocre chef, and with the hair he hides in the hat. It's a fun movie. Ratatouille is actually a delicious meal. And so I inspired by that. So they had this theme in the book that anyone can cook. And I'm like, okay, well, what if anyone can code? So can code. And so, inspired by that, we made up these slides. There was a little program about this, how we code in Python. But anyone can code in Python, okay? So here's some stuff about Python. No worries about this. I want to get you to because I covered those in the slides, and you're gonna go over these yourself, okay? All right. So this is where we start with core Python functionality. Python has a bunch of key core functionality, including the ability to define variables, strings, which are words and characters, lists, and other types of things, other types to store data. In the end, you're only working with data when you're programming. Okay, so let's get started. Variables. In Python, you can simply declare a variable by writing the name of the variable on the left-hand side, putting an equal sign, and assigning a value to it. So here, my var is a variable called myvar, and I'm initializing it, assigning it the value of 33. Now, Python is smart enough. It sees 33, and it automatically deduces that this must be an integer. Okay? It does that for you. If you're doing C++, you would need to do int myvar equal 33, right? In Python, it's not strongly typed, we say. The type of the variable is not strongly defined. Python does the job for you, which is great. Okay? Now, so that declares the variable, myvar. Next, your first syntax word that you're going to learn today is print. When in doubt, print it out. I'm going to repeat this. You're going to come out of this class, and we're going to give you T-shirts saying, when in doubt, print it out, because that is going to be your best strategy to understand what you're doing and what your code is doing. So if you just simply say print myvar, what it does, it's not going to send it to the printer, hopefully not, or it will just kind of print it just under it, okay? So if you have a Jupyter Notebook open with you now, feel free to open it up and just type in what you're seeing here. In your homework, you're going to go through these slides, and you're going to repeat every word we have there, and you're going to play around with that a little bit so you can get more freedom and more comfortable with basic Python. If you've seen Python, this is probably just boring for you. That's fine. Just bear with me for the next few minutes. If you haven't seen Python before, it's not hard. Okay, it's not hard. It's just a place where you just type things in English, and it allows you to manipulate data. Okay. So next, you can multiply this variable or do an algebraic operation on it. You can add, multiply, divide, or subtract. Okay. In this case, I'm multiplying it by 3.0. I'm doing many things here. I'm multiplying my var by a number, 3.0, which is a constant, okay, and storing this result in a new variable called b. So with programming, the left-hand side is saying, technically what the programming is doing in the background, what the code is doing in the background is saying, I want to create new memory in the computer to store whatever is on the left-hand side. So what we're saying here, we're telling Python, create a new memory. We're going to refer to that memory as b. And inside it, store the value 3.0 times my var. What is my var? My var is 33. It multiplies it by 3.0. Now, Python thinks 3.0 is not an integer. It's just a general rational number, you know. It's a floating point, okay? Although it's 3, but the fact that I have 3.0, it's telling it this is not an integer. So it automatically converts b internally into a floating point variable, and then you print it, it gives you 99.0, okay? So it turns it into a float. Now, you will see as we start coding together, rarely do we interact with integers. Every number I declare in Python, I always put 0.0 next to it if it doesn't have any decimal digits. Okay, I put 0.0 to tell Python this is a floating point number. Okay, so we learned a couple of things now, that multiplying an integer with a floating point number is going to be a floating point number. You can just apply operations on algebraic operation. You can put plus, minus, or division over here between a constant value and another variable. Okay, and then you can print that variable. Okay. Strings. Strings are a special type of variable that represent text. Okay, so these are things that you might, typically we don't operate on strings in numerical methods, but you might need to store a list of strings. Let's say you are doing some plots and each curve has a different name, like this is H2O, this is CO2, this is oxygen, etc. You might store those words in a list, and then when you finish the plotting, say, automatically put the legend on the plot, the first curve is my first value in the string list, and so on and so forth. So there's usually a need to store words in your programming to refer to something, okay? So those would be strings. Simply use to declare a string, to create a string, simply use single or double quotes to define a string variable. Like if you are doing in C++, like for the life of me, if I remember if I should do like double quotation or single quotation mark to refer to that, right? So Python is very forgiving. Like what I'm doing here, I'm declaring a variable called str1 for string 1, and I'm calling it, this is my first string variable. Notice the single quotation marks, and Python automatically color codes it for you. You'll notice that in this scheme, strings are all in red, okay? Print str1 is going to print that variable, and indeed it prints, this is my first variable. Okay? Now, next, I declare another string, str2. This is also another string. Print str2, this is also another string. Duh? Okay. So now, you ask yourself, what kind of operations can we do on strings? Can we add them? Absolutely. What does it mean to add two strings? Just place them next to each other, concatenate them. Okay? So you can concatenate two strings together simply by using the plus sign. It's incredible. If you think about mathematics, okay, if you think about math, there's like no defined operation of addition on words, right? What is the sum of two words or the product of two words? There's no such thing, right? But here in Python, they allowed us to define plus as simply putting two strings next to each other, okay? Just combining them into one other string. And we call that concatenation of strings. And here what I'm doing, on the right-hand side, I'm taking string 1 and string 2, which were already defined, and I'm storing them in a new variable, string 3. And see the result. This is my first string, which is string 1, period, and then this is also another string, okay? You can add extra strings between the strings. Notice here, there was no space over here, and there's no period at the end. So what I'm going to do, I'm going to take string 1, and I'm going to add a space, empty space, and then add string 2, and then add a period. And this is what happens. Okay? Straightforward, basic operations, very, very easy stuff. Okay? All right. Now, strings represent an immutable list of characters. In other words, internally, what Python is doing, it's taking that string. It's not storing the whole string as a variable. It's actually storing each and every character in those words in an array. Okay? It's storing those in an array. Now, when I say immutable, it means you cannot change any one of those characters. Okay? You can access any one of the characters in a string, but you cannot change them. So, for example, if you've done any kind of programming, you remember maybe you can access the value in an array by putting a square bracket and putting the index of the array entry. Well, if I say string 2 equal B, I'm going to try to change the second character or the third character in the string list and set B on it, is going to tell you object does not support item assignment, because we cannot assign a value, we cannot change any of the characters in that string using this method. But you can loop through a string. I'll explain the for loop later. Anyway, okay. Tuples. This is another type of so I'm just going to discussing the basic built-in bare bones types or things you can do in Python that we're going to use a lot. Okay, we're going to use all of these things in our coding. Okay, tuples are an immutable sequence of arbitrary objects separated by commas and enclosed in parentheses. So why would you need something immutable? It's because you strictly don't want any opportunity to make a mistake and change a value. Why would you need an immutable variable? If you want to make sure that you're not changing that variable, let's say you have, information about density and gravity on Mars, right? Those are fixed, constant. You don't want to change them. You put them in a tuple, for example. Nobody can touch them. You cannot touch them later. You cannot change them unless you make a conscious decision, go back to the beginning of the code and change the values. So that's the value of an immutable object. But what's great about tuples is that you can combine apples and oranges. So here I have a tuple that I'm storing in the variable A. It has a number, the number 1. It has a string, B, and it has the number 2. So we're combining different types together into one container, okay? It's called a tuple. You can access items in a tuple by simply opening up a bracket and putting a number in there. Now, things in Python are indexed from 0. What that means is that to access the first entry in A, that's technically A0, not A1. MATLAB is 1 based, so you start at 1. But Python is 0 based. So the first entry in any list or array or tuple or anything that is a bunch of things always starts at 0. So A0 is 1, A1 is B, A2 is 2. Okay? So if I print A2, it's going to give me 2. If I print A1, it's going to give me B. If I print A0, it's going to give me 1. You should try that. Okay. Now you cannot modify the contents of a tuple because they are immutable. So if I come and say A3 equal 2 or A2 equal 3 or something, it tells you I cannot, because a tuple object does not support item assignment. You cannot change the value. And actually A3 doesn't exist because that tuple goes from 0 to 2, right? So there's no fourth entry in it. Lists, on the other hand, are like tuples, but they are immutable. Okay? So Python developers were so kind to allow us to have immutable and mutable objects. Just like tuples, but they are mutable, but instead of putting them in parentheses, you put them in square brackets. And again, with lists, you can combine apple and oranges, strings and numbers. You can combine tuples. You can put tuples in, it doesn't matter. You can put other lists within lists, it doesn't matter. That's what we will actually use when we start doing linear algebra in this course. We're going to use nested lists. Okay, so my list has the numbers 1, 2, 3, and the character B. Again, it's indexed from 0. So my list 0 is 1, my list 1 is 2, my list 2 is 3, my list 3 is B. Okay. You can modify items in a list. So now I'm going to go change the last entry from B to A. So I'm going to say my list 3, which is the last entry in my list. I'm going to change it from B to A. I put A, it gives me A, indeed. Again, if you want to check what you're doing, just print it out, okay? And you can append items to a list by simply, so let's say you started with a list and you're storing, let's say your errors. You're computing errors as you go and you're adding on the fly, you're adding more and more and more errors. So you would have a list where you store the errors in it. But then you have more errors to add. What do? You just append them at the end. You say my list.append something. Here we're appending the number 43 to my list and just adds it at the end, okay? You're going to go through this in your homework assignment, but I just wanted to give you a head start. You can also insert items in a list at a specified location. Occasionally, not always, you might need to insert something over here, for example. Okay? So you can do that by using mylist.insert. We're going to insert it at index 3, so index 0, 1, 2, 3, and we're going to insert the item here, and there you go, it does that for you. Okay. Little things. You can create a list of lists as well. So this is a list of lists. See the outside brackets, and inside them I have a series of 3 lists. This looks like a matrix, a 3 by 3 matrix, and that's what we're going to use to represent matrices as we move on with linear algebra soon. Okay. You can also create an empty list. This is my favorite of everything we covered so far. This is going to be one of our go-to things to do. Create an empty list and start filling it with things. Because we're going to be doing a lot of for loops and while loops. We're going to be analyzing things. And once you have a result, you want to put it somewhere. So you create an empty list and keep adding to the list. Okay? So you create an empty list like this. Empty brackets. I feel I need sunglasses every time I go close to the board, like this sunshine comes in my eyes. So I keep stepping back. So x equals an empty list, and then you append 1, and then you append apple, you append whatever you want. It just keeps adding that to the list. When in doubt, you print it out, you print x. This is indeed what it's doing. Okay? All right. Let's see. Now, for scientific computing applications, we're not going to use any of those. We're going to use them occasionally to store, like I said, errors and things we're looping. We're not going to store tuples necessarily, but we're going to use a glorified list, which is called a NumPy array. NumPy arrays, they take the concept of the list, they make it purely dedicated for scientific computing, but you can only store numbers in those lists. You cannot store strings or apples or oranges. You can only store numbers in NumPy lists. We call them just NumPy arrays. Okay? More on that later. You're going to do that in your homework. Now, I want to warn you of something. If B is a list or any variable, like even a NumPy array or some other fancy object in Python, when you say A equal B, it does not create a copy of B. Instead, A and B both point to the same data. So what that means, let's say you start by creating a variable called B, and you put a list, you put 1, 2, 3 in it. And then you go, OK, let me make another one because I want to try something out without touching B. So you might be inclined to say A equal B, and let's play around with A, thinking that you're not going to mess B because B should be untouched. Okay? Well, it turns out when you do this assignment, if you modify A, you're going to modify B. We call this variable assignment by reference. So both A and B in this case, they're pointing to just one location in memory. So Python does this for efficient computing. If you really want to make a copy of B, you have to tell Python, make a copy of B. So I just want to warn you about that because it's going to show up in a few of our assignments where you think you built an array, you solved it, you built something, you solved it with one methodology, but you ended up modifying those values. You go to solve it with another method, turns out those values have been modified. So you should just be careful of that. To give you an example, so let's say B is 1, 3, and 5. We create a list called B. So if you print it, this is it, 1, 3, 5. Now we create A equal B. In this case, A is indeed equal to B. A is also 1, 3, 5. Now I'm going to go and modify A. I'm going to say A2 equal 1.11. So the last entry in A, instead of 5, is going to be 1.11. So now A becomes 1, 3, and 1.11. But also this changes B. Okay? This also changes B. So if you go back and print B, it's actually changed to 1.11 as well. So be careful of that. To avoid this problem, you need to explicitly make a copy of B. You need to say A equal B dot copy. Make me a new copy in memory of B. OK. So let's see what else is there. Yeah, so I'll let you finish the rest of this. There's over 100 slides in this. This is part of your homework 1 assignment. You don't need to turn in anything for it. Just say that you went through the slides. But I'm going to rely on you that you went through the slides, because once we start coding together, on Tuesday and getting more coding, I expect you to have known at least what a list is, what a tuple is, what a NumPy array is, etc. All of this is explained here. Okay, this is a great start, a great resource for you to at least get your feet wet in what we're doing in Python. And frankly, once you know these things very well, I will help you get through the finish line. Okay, in class, we're going to do a lot of programming together. Okay, so let's see. This thing keeps position on screen, bottom, go back. Okay, I'm going to go back to the slides. All right. Clearly, solving. Okay, so we're going to jump out of. Actually, before I do this, let me show you. Let me go through something. Okay, more on Python. Actually, more on Python. This is your captain speaking. Okay. They all have like these deep voices, like, this is your captain speaking. Okay. So, I'm sorry about these slides. They're just so silly. All right. I want to show you a snippet from a great movie. Maybe you've seen it, maybe not, we'll see. But that kind of motivates you for programming. Okay?
What's it going to take to make this thing worth the price tag?
Well, we're just getting up to speed here, Mr. Harrison. I need more manpower. I need programmers, folks to feed the cars.
We'll get them to crying out loud. Do the IBM, right?
Yes, sir.
We'll pull them out of Scott if you have to.
Understood.
I'm not paying any of you.
When the first IBM came to NASA, it was not an easy transition.
No one thought to measure these things?
I'm afraid it was, sir. Nobody knew how to use it.
Computers were these big units that took up the whole entire wall.
There's more computing power in a toaster today than what was available to these people in the 1960s.
When Dorothy sees the IBM being built, she learns how to program them.
She realized really quickly that the IBM was going to be the way of the future.
The IBM 7090 data processing system.
It has the ability to solve problems that cannot be solved in a lifetime of manual labor.
What's your name again?
Dorothy Ball. We need the IBM to let us launch.
We got a job to do. Whatever happens up there, it's in God's hands.
My guys are ready. Thank you. Ladies, we've been reassigned.
She basically saved her whole team's jobs and created a value for herself.
It's so funny what we think of as computers now and what they were then.
Okay, who's seen this movie? Yeah, there you go. It's one of my favorites. Yeah, so you know the story. We're going to come back to this movie when we do the Euler method that puts Glenn in space, and so we're gonna learn that method as well. But if you think your life is miserable because you're programming in Python, I'm happy to send you to one of these IBM 7950 DPS with punch cards. Where you're going to spend a lifetime just to print out a print statement. Okay, so we are so better off with the tools we have. It's just incredible. Okay. All right. This is the stuff on. Take this away. Okay. This is stuff on anyone can cook. Okay. So here I wanna go back over why Python and to clarify the difference between Python, Jupyter Notebook, Anaconda, and a bunch of other things. Okay. So this will be helpful as well, especially if you're new to Python. So this chart, I got it from 2019 actually, and I was lazy to grab a refresher, but I looked up at the top 7 programming languages at the IEEE job posting, and you see like Java and Python head to head. But when it comes to scientific computing, if you specialize for scientific or web design and app, Python is number 1. There's over like 61,000 jobs with Python. JavaScript, half of that, C++, etc. So you don't even see MATLAB there. So we're doing the right thing. You're doing the right thing. Learning Python is going to be good for you. Okay, good for your health and your future. Okay, now what is a Jupyter Notebook? Jupyter Notebook, it's an open source web application that allows you to create and share documents that contain code, equations, visualizations, and explanatory text. Jupyter Notebook has nothing to do with Python. The idea of the Jupyter Notebook it evolved with Python, but Python is only one option to use in a Jupyter Notebook. A Jupyter Notebook, you can run Fortran in a Jupyter Notebook. You can run C, you can run R, you can run Java, as long as you build the correct backend. It's just that the case is the standard backend for Jupyter Notebook is Python. Okay, so Jupyter Notebooks can support a lot of languages. Python is just one of them, and that's the one that ships with Jupyter Notebook. But you can customize it to do all sorts of other languages. However, you must install and use it locally. Now, when you combine Jupyter and Python, we can make things easier, by creating what's called a Jupyter Hub. Jupyter Hub, so now we have Python, which is the programming language. Jupyter Notebook is just a way to combine code, text, and plots together. It can use Python or other languages. Here, we're going to be using it with Python. So we have the programming language, the layer on top of it that allows us to write beautiful reports and everything in one place. And then Jupyter Hub is the thing that allows you to access Jupyter Notebooks in a web browser. No need to access them locally. And that's what you're doing when you go to ondemand.chpc.utah.edu. You're just connected to the hub, and you can run instances of the Jupyter Notebook. Do not confuse Python, the core programming language, with Jupyter, Jupyter Notebook, and Jupyter Hub, which is just a web application where you mix code, text, and figures. It has nothing to do with Python. Anaconda, don't confuse Python with Anaconda. Anaconda is just a very popular distribution of Python and Jupyter. You can use it to install Python and Jupyter on your computer. And finally, some of you might have heard, do I need to use PyCharm or Spider? Again, PyCharm and Spider, they're what's called integrated development environments. So as opposed to Jupyter Notebooks, if you want to program some serious heavy-duty code, you don't do it in Jupyter Notebooks. If you're building applications with thousands and hundreds of thousands of lines of code, you don't do it in Jupyter Notebooks because it just cannot handle that. You do it in a code editor, an integrated development environment that combines debugging features and fancy stuff. That's what it is. Spider and PyCharm, they're just code editors. But they don't provide you the capability to blend code and text together and visualization. Now, some new developments like Visual Studio Code or Google Colab are kind of variations on the Jupyter Notebook. But still, Jupyter Notebook still stands as the winner, in my opinion. OK. So this is what we got here for Jupyter and Python. With that, I'll switch to my last two slides, and then you'll take a break. Solving problems in this class, that's what we're going to be doing. We're going to be solving a lot of problems. Some problems might be easy. Some of them might be harder. But the point is, there's always a strategy to solve a problem. First, you need to identify what you know and what you are trying to find out. You just list them. Just write them down in your notebook. Say, OK, I'm given the perimeter, the area, the mass, etc. And I need to compute the temperature. I need to compute this. I'm given this equation. I need to solve for x, right? I'm given this system of equations. I need to do this. Write down the solution procedure. That's the algorithm. That's the programming step. What you need to do, you can write it in math and then think about your implementation. OK, when possible, separate different aspects of the problem into small pieces, okay? So you have a nonlinear equation. First, we need to linearize it, and then after we linearize, we need to solve the linear system step by step, okay? You go step by step. Test the solution on a simple test problem by hand. So we're going to be, for example, I might be asking you to write a code, a generalized code that computes derivatives, okay? First, you need to check that your code works. So what do? You test it on a problem where you know the derivative, you write it by hand on a calculator, you run it through your code, you're like, OK, good. The code gives me a consistent result with my calculator, with my hand calculation, with my neighbor, OK? So you do that, you test it on a small problem, and then you do the bigger problem. And finally, you plan your numerical implementation, and in connection with the math, your code generally will always represent the math that you set out to do. And to the extent possible, you should separate your code, your implementation into functions or Python routines. You'll learn about that in the slides, in the EasyPy slides, but also we're going to be working on those together. It's not required. Again, I'm not asking you to write Shakespearean level code, if Shakespeare wrote code, but you know what I'm talking about. I mean, you don't have to use functions. It just makes your life easier. Okay, and that's my intent, is eventually to become a better programmer too, through numerical methods. And then you test your code on a simple example, like I said earlier, compare with your hand calculation or your calculator. Okay, I have a list of action items for you to do from Tuesday or today. Review the syllabus, please, in full. Understand the class policies regarding homework, grading, exams, everything. If you have questions, feel free to ask me or ask Cadmus TA. Okay. Install Python or alternatively register for a CHPC account and use our online Jupyter Hub. Subscribe to my YouTube channel. Again, tell your family, your siblings, everyone, go post it on your Facebook. Okay, increase the number of subscribers because it triggers the algorithm and makes these videos rank up higher, so we reach more people in the world. Eventually, this actually feeds to our graduate program. And we get a lot of students coming from, so a couple of other professors have big YouTube channels as well, so we use them as recruiting tools. Make sure you can log into Canvas, and make sure you receive Canvas announcements and Canvas emails. So if I make an announcement, like tonight I'm going to make an announcement, exam 0 is going to be next Thursday, this and this and that. Make sure you're going to get an alert about that, and that you can log in on Canvas and see that announcement on Canvas. All right. Find out where the help sessions are. So go down to MEB and see where the space is. Oh, our TA, Lillian, is here today. Hello. Yes. Yeah. So those two people over there are going to be very essential in your success in this course. Okay. So Davin and Lillian again. So they have a nice table with a nice, CHEN 2450 little thing over there. Okay. Find out where the help sessions are and add the help session times and dates to your calendar. Okay. Find out where my office is. I'm right across that lab. Okay. Again, if my door is open or just like hanging out, feel free to just talk to me. Okay. Or we come through office hours, or we schedule an appointment. And start on Python, where I said those EasyPy slides. You're going to start there. It's going to be part of your homework assignments. All right. Let's take 5.